This PPT on antenna fundamentals is designed for BSc and MSc physics student according to NAP syllabus of CSM University. Myself, Dr. Gupta, Department of Physics, DBS College, Kanpur. Now come to antenna theory. Antenna play a vital role in our communication system. It is simply the process of conveying messages at a distant places. The electronic equipments which are used in communication systems are called communication equipments. Different communication equipments are used in communication system. An antenna is one essential equipment among these communication systems. So now I am going to discuss about antenna in details. The various points in our contents are introduction and definition. Now, coordinate system of antenna, antenna parameters, types of antenna, decibels, field regions of antenna, and types of antenna, along with types of radiation pattern of antenna. Introduction. The first antenna were built in 1888 by German physicist Heinrich Hertz in experiment to prove the existence of wave predicted by electromagnetic theory of Clerk Maxwell. Hertz placed the dipole antenna at the focal point of parabolic reflectors for both transmitting and receiving purpose. During starting in 1895, G. Marconi began development of antenna practical for long distance communication, wireless telegraphy, for which he received a Nobel Prize. An antenna are our electronics eye and ear of communication world. They are our link with space. They are essential and integral part of human civilization. So the definition of antenna is an electronics conductor is interface between the transmission line and space. It is also a transducer designed to transmit to receive electromagnetic waves. Radiation of antenna can be explained by using of capacitor theory. It contains basically two parts, transmitter and receiver. The transmitter radiates electromagnetic waves into space, and similarly receiver receives electromagnetic waves from space. In two-way communication, the same antenna can be used for transmission and reception purpose. The electronic symbols of antenna is given as along with diagram. Now, coordinate system of antenna. The antenna coordinate systems are often used to specify the position of point, but they may also be used to specify the position of more complex figure such as line, planes, circles, and sphere. An antenna coordinate system is implicit in almost every antenna measurements. Terms such as patron main and cross component, beam pointing with peak gain imply the definition of directions or vector field components which are required. A coordinate system is very important parameter for measurement according to coordinate system of antenna. Both the vector component and direction parameters must be defined with respect to a spherical coordinate system fixed to antenna. So the diagram of coordinate systems are given as these diagrams in details I will discuss in next PPT. Now come to antenna parameters. To design an antenna, following characteristics of parameters are to be taken into consideration. जैसे रेडिएशन पैटर्न क्या होता है, पावर डेंसिटी क्या होती है, रेडिएशन इंटेंसिटी का वेरिएशन क्या होता है, बीम एरिया क्या होती है, बीम एफिशिएंसी कितनी होगी, एंटीना गेन कितना मिल रहा है. दिस इज जस्ट रेशियो. Antenna apertures, very important parameter of antenna for antenna, effective height, directivity, and power gain. So next slide is types of antenna. There are 5 types of antenna in communication system: isotropic antenna, dipole antenna, half wave dipole antenna, quarter wave vertical antenna, and last parabolic reflective antenna. Now, isotropic antenna. An isotropic antenna is defined as hypothetical antenna having the same radiation in all possible directions. It is assumed that the power gain of isotropic antenna is 1. So, very ideal antenna for communication system. The symbol of isotropic antenna is also shown in a figure. Now, come to dipole antenna. A dipole antenna commonly consists of two identical conductive elements such as a metal, wire, or rod. One advantage of these antenna is it picks up the radio frequency speedily. These radio frequency enhance the reception of TV and radio. And also you will get better sound and pictures on your TV with help of dipole antenna. The diagram and symbols of the dipole antenna is also given in the figure. Half-wave dipole antenna. It is very important important antenna for communication system. An antenna having a physical length that one half wavelength of the applied frequency is called half-wave dipole antenna. This antenna is not used at a frequency below 2 MHz because of physical size needed of antenna to represent a half-wave. The diagram of half-wave dipole antenna is also given in figure. Quarter wave vertical antenna. The most common form of quarter wave antenna in which the antenna height is approximately 1/4 of the wavelength of electromagnetic waves. It is used at all frequency bands excluding low frequency, medium frequency, high frequency and very high frequency range. Parabolic reflective antenna. It is used as high gain antenna for point-to-point communication system. Most important use of parabolic antenna as a radar antenna which need to transmit a narrow beam of radio waves to locate any object in the space. They are also used for weather detections. The diagram of the parabolic reflective antenna is given as. Decibel is a logarithmic unit used to measure sound level. It is also widely used in electronics, signals and communication system. A dB is a logarithmic way of describing a ratio. The ratio may be power, sound power, voltage, current or different other parameters. Used for all mathematical calculation in the communication system, decibel system is used. Decibel is logarithmic number. 1 dB, this is dB is equal to 10 log linear number. Linear number may be 1, 2, 3, 4, 5, so on, etc. Just like gain 2 is equal to 10 log 2 is equal to 3 dB. Similarly, gain 4 is equal to 4 log 4 is equal to 6 dB. It means when number doubles, dB goes up 3 dB. When number is reduced by 1 by half, then dB goes to down. This is very important decibel system for communication electronics as for antenna. Now come to antenna array. Antenna array is a group of antenna or multi-elements having the some spacing and arranged to provide the desired direction characteristics. An antenna array can be used to increase the directivity either transmitter or receiver antenna. It have following parts. Driving elements and parasitic elements. Both two parameters are very important for antenna array. Just like we know that driving element, it is directly connected to transmitter and identical to a dipole drawing power from a transmitter. Similarly, in the case of parasitic element, it is close to driving element to allow coupling for production of maximum energy. The arrangement of antenna as antenna array is given in the figure. Types of array. There are many types of array. According to their directivity characteristics, the antenna array are following types: broadside array, end-fire array, and long period dipole array. The field region of antenna. This is also very important. The field surrounding an antenna is divided in 3 regions: reactive field region, radiating near field or Fresnel regions, far field region or Fraunhofer regions. In diagram, reactive, radiating near field, far field region are shown in the figure. Radiation pattern. Generally, antenna are oriented in a such a way that at least one of its principal plane pattern coincide with one geometrical plane. Radiated power from a practical antenna is more in some particular direction and less or null in some other direction. The energy radiated in a particular direction is measured in terms of field strength or flux density at a point which is fixed, a radial distance from the center of the antenna. The measurement can be done in the Fraunhofer region because basically Fraunhofer region is very effective region for measurement of radiation pattern. Radiation pattern. Now come to radiation pattern. An antenna radiation pattern is defined as a graphical representation of a radiation properties of antenna as a function space coordinate. In most cases, the radiation pattern is determined in the far field region. Overview of antenna radiations regarding near and far field. The field patterns generated by a radiating antenna vary with distance from center and are associated with number 1 radiating energy, number 2 reactive energy. The space surrounding an antenna can be divided in three regions. Basically, we know that the space surrounding the antenna is called, this is field region. This field region have three parts: reactive field region, radiating near field region, number 3 radiating far field region. The boundaries of these regions are mentioned in given diagrams, are not defined precisely, but only approximation are taken. Thank you.